and good afternoon. My name is Adam Mikowski. My sharply dressed colleague over here is Srilak Moram. We're from American Water, and we're going to discuss what we did with Internet of Fleet Management things. So a little about American Water. We're the largest and most geographically diverse public water utility. We do water and wastewater distribution and treatment. We're in about 16 different states. I can't really count, but our regulated business is in the gray states, and our non-regulated business is all over in the darker blue. And the lighter blue is a mix of both. Now, one thing that's important to us at American Water is that we value the customer and, most importantly, the customer experience. And what we wanted to do when we set out on this is, using big data technologies, provide insights into our fleet management, driving behaviors, and route effectiveness. And the way that ties in is that our FSRs, or field service representatives, are the first line of contact with the customers. They're going to be changing meters, reading the meters, addressing any leaks, things of that nature. And if the customer doesn't have a great experience on that, or the field service representative got hung up from traffic or something like that, then the customer is not going to have a great experience. So we wanted to focus on that and offer insights into their driving behaviors and their route effectiveness. And more importantly, this solution had to work on an iOS platform and support offline work, because FSRs aren't guaranteed to be in cell phone reception. Sure, if we're in a city, we'll constantly get data, but there are many cases. Let's say one of our states is West Virginia. It's in the mountains. There's no service in certain locations, and it's going to be in and out. So that's one of the reasons why we needed offline work. A little bit about our environment. When we did this, it was on our Hortonworks data platform. We used NiFi for ingestion, Kafka to route it to, and use storm topologies and streaming analytics manager from the HDF stack. And then after that, we stored all the data in Druid and time series database. And for analytics to offer insight into this, we put Superset on top. So here's a high-level architecture. Basically, the idea is our trucks are out there. They'll have these iPads in their trucks, and that'll be recording geolocation, speed. It could even record how they're actually using the iPad to complete their work as far as work orders. And that data would be transmitted to NiFi via site-to-site, and then go from NiFi into Kafka topic that we've set up. And from there, we would take it using Streaming Analytics Manager to route it into a Druid sync. A little bit about the app implemented in Objective-C. The data is sent via site-to-site using a Cocoa framework. And we built a queuing mechanism within that, so it would support offline work. So even if they're wherever they're at and maybe it's not transmitting, it'll capture the data or that's relevant and store it for up to 24 hours. And then once they get back into service or something like that, they'll be able to, that data will then be flushed out and then sent into NiFi. One thing I wanted to note, when we implemented all this stuff, it was a little bit ago. We didn't have all the tools and capabilities that we do now. For instance, NiFi would be a great application, or this would be a great application for NiFi and to collect data in the sensors and like specific to the truck. And maybe this type of scenario is more well suited for how the FSR would work within the iPad and using the software that's there. So the data points we captured here is a simple subset: device ID, username, event time, longitude and latitude, and then the address. And we captured it as a JSON, and from there, that would then be pointed into, or sent up site to site to NiFi in Sri Lanka.
Yeah, thank you, Adam. So this is our typical NiFi flow. So you can see there is an iOS event mock. So we are doing a mock processor which sends a data in JSON format. So and there is also a site to site you can see from through NiFi. So from the app, iOS app, we are doing a site to site to NiFi. So we are doing both the things here. So here we are updating attributes so that so we can define a schema beforehand. So what is the device ID, longitude, what format is the data type you needed. So we can declare it here itself. And in the backend we use Hortonworks schema registry. So which is like a which has all the schemas where we can declare everything. And here we use a convert record processor. So why we use it? It's for converting the record which is in JSON to Avro format. And this is the published Kafka processor, the way we configure. So here we can give the topic name where you want to send your real-time data to. So if your load is very, if your data is too much, you can increase the performance using partitioning and replicating the Kafka topic once you create. So this is the SAM Streaming Analytics Manager. So if you want to perform some transformations on the fly, like aggregations and something, you can do that here using Streaming Analytics Manager.
Also, one thing to note there, at endgame we were putting the data in Druid, but if we wanted to keep the data raw, we also dumped it off into HDFS as another place to sync the data.
Yeah.
And
we can use HDFS or we can dump into S3 bucket or something.
Just in the context here, we're using Druid.
Yep. And this is how we configured the Kafka, and it has its own consumer group. You can create different consumer groups if you want to point to a same topic. And here we are dumping all the data into HDFS. So here for the visualization part, once we have the data in Druid sync. So this is a superset where we can visualize the data. So these are this is our dashboard where we can see all the analytics.
Right. So from here, we'll actually go into quickly showing actual data coming through. So this is just a simulator that I have set up based on the code, and it'll continually send in a file, and the simulator is running a route in California. So switch to here. And up here. Let's go to NiFi first, since that's where it's coming through. Come on, Mac. All right. So as you can see, we're starting to from app input processor within NiFi. There is another input port on the root canvas that routes to this one. We're starting to see flow files go through here. And like Sri was mentioning before, it was going through the update attribute to grab the schema name that's going to then use in the next processor of convert record, and use that to convert the JSON into Avro. And then from there, it's simply just publishing into Kafka. And from that, if you want to go through the, we're starting to see more stuff come in. I don't know. You have anything?
That's it. So we can do all the analytics here. So so at what point of time the truck is, and how many services has been completed, and if somehow the truck is stopped in some way, so we can correlate with weather data and we can see what happened. And so there is a much interaction. So there is no latency, and we can see as it is from different users. And this is a supply chain distribution where it routes.
All right, and one problem we have in American Water is, and some of our FSRs don't like it. The trucks have GPS things in them, but they don't necessarily like the idea. They'll turn it off. I don't know why, but they'll do that. But this will be able to, you could set up something like events received by user. For some reason, if I were to, I don't know which one that is, but you'll see that there's an uptick in whatever this stream is, or this one down here, I think. You can basically look at the events, and then at a certain point you can judge. It's like, oh, this user all of a sudden dropped off the map. What's happened with him? Is he all right? That's another thing that we're concerned with at American Water, is safety of our employees and our customers. This provides insights that we didn't necessarily have. Even if the GPS was still going off, or what we have currently now, we wouldn't be able to get some of this information. And yeah, and from this, you can have it configured to it's constantly updating, so you're not only, oh, that's why this hasn't updated yet. So let's hop into there. So there, and you can start to see other data points coming in, moving on the route. And this is simply that. What else? That's pretty much what I had. Is there any questions around this?
So, is this sensor data which is coming from the truck continuously, or?
Yeah, so what we have right now is the simulator running, and if I were to go back to NiFi, the constant, actually you can see it here. This communication, that's communicating with our NiFi cluster down there, and all the data that it's capturing, even though it's a small subset right now, that's being sent through the whole stream from NiFi into Kafka and then into Druid, and then being exposed on Superset there.
Okay, so all the online data, the truck data is directly flowing into your NiFi cluster. So, or are you doing some transformations even before it goes to NiFi?
Coming from the app, right?
Yeah, right now this is coming from the app. This was a use case that we did.
Okay.
Yeah.
So all our analytics will be performed on the SAM UI, where you can do aggregations and transformations.
Because I'm coming from a train company and we are doing a lot of analytics.
Okay.
Very similar to that, so I was just curious on how you're getting
So,
data on an, and I'll touch base.
Yeah, this is something that you could put on an app, or like I was mentioning earlier with NiFi and sensors, if you wanted to have those separate from a device that's just in the truck, then you could use NiFi to then communicate to your NiFi cluster and pretty much do exactly what we did with NiFi, and bring it in site to site, write it to a Kafka topic, and take it from there. At the time, we didn't have NiFi to work with, so we went with using a Apple or iOS app to do this, and that's what we have right now.
So for the streaming part, we are using Storm, so we can use Spark also. Yeah.
Are you planning to migrate towards Spark more in favor to over Storm, or what do you see as the future of Storm?
So as we have the dashboard streaming analytics manager, we are using it, but we can use Spark also. It's relatively fast. We need to have some streaming mechanism where it connects to a topic and pull the data. Yeah.
Could you go back to your supply distribution chart? I didn't quite understand the point of the spiral.
Yeah, that one was, so that one did look like a little bit of a mess there.
Well, I was just trying to understand.
Yeah. So I mean, some of these we were mainly demonstrating different things that we could tie within Superset. The supply distribution one, it's not a great example, but from there, like, this is more of, we wanted to show different things that we could do within Superset to visualize the data. There's a lot going on there that's not necessarily going to be very informative for someone to take a glance at, but mainly these up here would probably provide more valuable information for someone to go in and look at the data coming in.
And what is Superset? Is that a dashboard?
Yeah, I think it was developed by Airbnb. I don't know if it's like full, like production grade. GI, is it GI?
No, it's under technical preview.
Okay.
Always sold as HTTP, but yeah, it's Superset. It's still version 0 point something.
Yeah.
Technical. It's an Apache incubator right now.
Yeah. So it's a technical preview, and we wanted to do it because we could get it and do some pretty cool visualizations with it. But you can pretty much point it to a source, make some slices, which is basically what these are, a map box or a bar chart, line graph, and then put those in a dashboard and configure it to refresh at a certain given rate up here. That's why we chose it, because like you always want to see an update, where are my people moving or something like that. So.
And for different IoT, you can use MQTT or co-op, any protocol, you can get the data.
Sure.
What kind of processing is done by Storm in your workflow?
So Storm do nothing. It's like, think as if it's a Spark streaming. So it pulls the data from a topic and push into Druid. Yeah. So if you want to perform some transformations, you can use SAM-UI. Very good.
It reads Kafka, reads from Kafka and then push it to.
Yeah, Druid sync.
Allows you to do advanced analytics too. So, but difference between Spark and Storm is Storm has very, very, very low latency, like sub millisecond. Whereas Spark doesn't quite have that millisecond range. Because Spark streaming Storm is faster. It all depends on what you define as code.
You look like you had a question. Where did we put it in the HDFS? Yeah. So that's handled within the Streaming Analytics Manager. Unfortunately, my access to it isn't working right now, so I can't show it. But where was it? I want to look at it. So where was it? So over here, we're taking it from Kafka right here and simply just dumping the raw data in the HDFS. And over here, we're just configuring, I guess, that I'm a NiFi guy, so I'm going to call it a processor. I don't know if that's the actual terminology, but we're configuring where it goes within the HDFS and all that. And it's just dumping right now. So everything's coming in basically. Each flow file has a record of content, so it's dumping those within that. Ideally, I don't think we want to put in tons of tiny files within that, so that might be something to work on there. Any other questions?
What about like some of the seeing what you're doing with the data in NiFi? Can you show it from start to finish, or is it able to see what's happening with the data, how it ship it?
Yeah, we can do that. Let me stop this here. Actually, that reminds me, there was something else I wanted to do as well. So looking at one of the flow files here and its content, that's not really nice to read, but it brings in all the data, and this is as JSON. Speed's coming in there as well. I think that's not a dynamic value right now. And then From there, after the convert record, it'll then transform into Avro. But to kind of show that we're not just messing around as far as the data going into Kafka, not tricking you guys, one thing that we can do in these mock events. This is simply, it's writing JSON and it's going straight into the convert record. There's some examples of that within Superset. Let's change this to and I don't know, we can keep that the same. So right now, John's not out in Superset, but if we start playing this, go over to Superset, we should start seeing his name appear. Should, unless you put a filter on this.
Yeah, refresh the dashboard.
This entire thing. Oh wait, you know what? I don't think there we go. So here he is, showing up, starting to do work. Or sending events, rather. And I don't know a quick way to take all these off, but he's showing up within, we got an uptick in John showing up on the data out here. So it is going through and coming up real time.
Have you thought about any predictive analytics opportunities in this use case?
I haven't, but it's a good question. So we could use it in a way to tie it with traffic data or something like that. If we know an FSR is traveling down a major highway around a certain time, or like we have an order that's scheduled or this is the likely route to go, maybe we can reroute the person to a better route to get there on time. I'm certain that there's many cases. I haven't thought of them recently.
Do you guys do any route optimization or anything like that?
A specific, like within the data group, not yet. It is something that's up there for us to take a look at. Right now, we want to make sure we're capturing all the data. There's existing stuff that we've done where we've looked for route optimizations, but we want to take that into the big data space and expose it to the tools that are out there. Because right now they're on like our enterprise software. There's not much we can do within that, but once we get that data out and into an environment where we can work with it, that is something that we would want to do. You back there?
Question slightly different. So when it comes to IoT, right, so how do you, when you're collecting data from all these devices, how are you making sure the data is coming, is it not noise, it's coming in from a secure, it's the same data?
That's a good question. You want to take it? So as far as that hurdle, we haven't necessarily tackled yet in this scope. As far as secure, we've looked, so like plant sensor data, that's something that we definitely wanted to make sure is secure.
So,
Oh.
which is on a same VPC. If it's on a same VPC, like our water plant, where we have all the sensors, so they are on a same VPC. So it's like internal network. So that's how I.
No.
How were the Apple devices configured to send out this data? So was there an installation done in these? So what exactly was done on the devices?
So right now, not everyone in our field has these. This would simply be something that we could run in the background and have capture the data. They wouldn't necessarily do what I just showed you guys, where I kind of they have to go in manually, then turn something on. We wouldn't have our employees do that. The idea is to basically do what I was saying, is just they go in, work, they don't know that this is there running in the background, or they know but don't necessarily mind it, and that will be capturing relevant data and then sending it into our cluster. And it would just be something that was standard issue on our tablets.
Usually you push out apps through like some sort of MDM software, MDM is
Yeah.
mobile device management, so we're able to, a lot of enterprise ones exist, so depending on what you have, once you build the app in-house, you can actually put it into your landscape, and then you use the MDM to push it down every device that is attached to that MDM. Right? So in a situation like this, if everything's purchased by American Water, and American Water distributes it, essentially when they load their image up, they can actually push the app down and then push the app out.
I thought the answer to his question was going to be you're using Location Manager in iOS, right, to collect the data? Is that?
Yeah, we are. So Location Manager, yeah, that does collect the geo coordinates and all that stuff. I believe were you more going towards how we would distribute that, how it would work actually out in the field and distribute the software to those, or more how to collect the data?
Yeah, the data collection.
Yeah. Oh, okay. Yeah. So the data collection, we're actually using a location manager, like you said, which we can get geo coordinates or lat long, and we can do reverse address lookup with those on that. So that's how we got some of the data points that we're using here.
Is that your devices that you're putting on the trucks, or is it on the employees, like their phones?
So this would be on a tablet that's that's kind of like mounted into the truck.
So it has a GPS inbuilt and it has accelerometer. Everything we can calculate on the phone from every mobile device.
Anything else? No? Oh, a couple more.
I was gonna say, I'm sorry. Go ahead. What's like the size of your NiFi clusters?
As far as like
Like resources?
resources, what we got? I had a slide briefly. You should know that. You should forget about that. Where am I? Sorry. So, yeah, NiFi cluster, when we did this, 16 core, 64 gigabytes of RAM, 5 nodes.
You mentioned an accelerometer. Is there any plans to expand into like, I guess, maintenance or driving pattern to determine?
So yeah. So once it was tied to the plates, we can get the real time.
Yeah, it's definitely something that this is the kind of initial to show, hey, this is what we can do. And there, obviously, those devices come loaded with different things, and we want to expand and capture all the different metrics that are within it. And that's just going to open up the possibilities for us. All questions? All right, that's all we got. Thank you.
Thank you.